Thank you. It's just like that. Yeah, I mean, I think they did it because for some reason they didn't need chemistry. I don't know if you noticed that. And so they were
Trying to check to make sure. I'm pretty sure tomorrow and Thursday,
Exactly.
the labs you're going to be doing, you'll be needing a long stick top or lab coat. Just check. And the answer is yes. You'll be needing a long sleeve top or lab coat for this lab this week. All right. Okay, I promised to go through the recommended problem set for carboxylic acids and their derivatives, so I better keep my promise. All right. As you remember, the hardest thing for me to hear is letters of the alphabet, so don't whisper them. On page 1, the question is, give the IUPAC name for the following. A, B, C, or D. Does anybody have a favorite? Oh, I heard someone say D. All right, I'll do D. And if we look at this, the question is, what's the IUPAC name? The first thing is, what functional group are you dealing with? Excuse me. And what's different? 2 oxygens, carbonyl hydroxyl group, carboxylic acid. Plus a bit of N. And how do you name a carboxylic acid? You count the number of carbons in the longest chain, including the carbonyl carbon. Name that as an alkane, 5 carbons, pentane. Drop the E, add OIC, add the word acid. No number, because the carbonyl carbon is always number 1. Oh, look, it's your old friend, the methyl group, and it's on carbon 4, so it's 4-methyl benzenoic acid. And if you look at B, B is the IUPAC name, which came from the common name, and that's benzoic acid. And then E, F, G. Anybody have one on E, F, or G? In that case, I'm going to pick one myself. Oh, let's do F. And the question is, what's the IUPAC name for the following? And what do? You look for what's different. And here, ooh. We have a, before I forget, have a carbonyl with an oxygen with a negative charge and a cation. In this case, it's sodium. And these are carboxylate anions or carboxylate salts. Either name is correct. I usually use anions, even though it's a salt. And what do? You name the longest chain with the carbonyl carbon, drop the E, add OATE. Propane becomes propanide. In the front, the metal or element this comes from, the cation, you use that name, so that's sodium propanoate. And here, same thing, potassium benzoate, benzoic acid, drop the IC in the word acid and put ATE, and then the cation comes from potassium. All right, let's look at H, I, or J. Any questions? In that case, let's do J. I hope you figured out I'm going to do one of each area, whether you like it or not. But anyways, let's take a look at this. And what's different? Carbonyl, oxygen, carbons here, carbons here. And we have an ester. And with an ester, How do you name it? The R prime goes in front. You name it as the alkyl group it comes from, isopropyl. And then you name the number of carbons along this chain. Octane, drop the E at OATE. Or the other way of doing that would also be what carboxylic acid is used to make that. If this were an H, it would be octanoic acid. Drop the IC in the word acid and put ATE. Either way, you get isopropyl octanoate, which is an ester. Speaking of esters, was anybody out this weekend and you smelled some of the flowers and things that are starting to grow? Did you think about esters? Because that's what you're smelling. Or did you happen to pick up a bottle of vinegar and think it has acetic acid, which is a carboxylic acid? If you would be shaking your head, yes. I'm getting through to you finally. All right. On test number 3, there'll be 2 types of nomenclature question. One is here's the structure, give the IUPAC name. The other is here's the name, draw the structure. And that will have both common and IUPAC names. And if we look at A is acetic acid, which is in vinegar. Also ketchup, mustard, relish, pickles, because they all have vinegar. And what is that? That's a carboxylic acid, or R is a methyl group. How do you name it? Let's do this compound, 2-ethyl hexanoic acid. How do you name the compound or draw this compound? You start this way and move from right to left. OIC acid, carboxylic acid. If this were an E hexane, 6 carbons. So I have 6 carbons, including the carbonyl carbon, carboxylic acid. And then on carbon 2, you have an ethyl. All right, E, F, G, H, I, or, oh, by the way, once in a while in problem sets I get carried away, cross off J. I'll never ask that on a test. Even though I did talk about it in class. All right, let's do a couple of these. Let's look at F. How would you know what to draw? Start this way, go that way. OAT ending tells you either have an ester or a carboxylate anion. Because you have ethyl in front, that tells me I have a carboxylate anion. And what do? You look at this and say OAT ester. If that were E propane, 3 carbons, including the carbonyl carbon. Oxygen, what's my R prime of the ester? Right here. And you look in the front, ethyl. Now, I got carried away here. I will never give you an ester that has an alkyl group on this chain. Because you can see the name gets very complex very quickly. And you say, oh, you forget a number? No, you don't. And I won't do that. So you can cross off G. But H I can give. And ethyl acetate is a common name for ethyl ethanoate, which nobody calls it. They calls it ethyl acetate. ATE ending. Ester from acetic acid. And what's my R prime? Ethyl. Anybody happen to look at your nail polish remover? Is it acetone or is it ethyl acetate? For many years it was ethyl acetate. If you went into a big box store, most of the wall where they have nail polish remover would be ethyl acetate. It smells better. If you have any little cuticles or cuts on your finger, it does not sting as badly as acetone. At least that's what I'm told. You can tell I use a lot of nail polish remover. Oh, I did. I took it all off. So anyways, and since they came out with the new, as again, I've been told by former students, the super durable nail polish, that doesn't come off as easy with ethyl acetate or acetone. So now you're seeing more acetone on the shelves being sold too. All right. Let's continue on. Next, there's 3 parts for test number 3. By the end of the week, I hope to have it posted. What are the point breakdown? I believe it's 9 pages. And first part is general knowledge. Next one will be nomenclature, give the name or draw the structure for a molecule. And the final part will be reaction 60 points, give or take a few. And there, most of them will be draw the structure of the organic product or products. So let's go through these. Let's look at A or B or C. And if we look at, anybody have a favorite? I'll do B then. And we look at B, what do we have? I have an aldehyde. What am I doing? Oxidizing this. You did this last week in the lab too. And what do you get? Aldehyde, oxidized, carboxylic acid. The H becomes an OH, everything else stays the same. Now, another way to make a carboxylic acid, E or F, ooh, I gotta do F, it looks pretty. Question is, what's the organic product you get from the following reaction? What's different? Ooh, magnesium chloride on a carbon, grignard, carbon dioxide. Second step, acid, water. You get a carboxylic acid that's one carbon longer than the R group you started with, in this case cyclohexane. The carbon with the grignard is this carbon, which becomes this carboxylic acid. I believe that's the only way I can easily think of making that compound is with a grignard. Any other way would be very complex. Now, if you notice what I did on A, same reaction, but secretly, I've been telling you, I've been inoculating you against the chemistry instructor's favorite trick on a test, and the ACS does the same thing. Put a big, scary R group, and ooh, a big, scary R group. No, it's just a Grignard CO2, second step acid and water. This gets a carboxylate anion, R stays the same. All right, now carboxylic acids are acids. Why? Because they have a proton they can donate. And if we look at the next two, B and C, the question is, what's the organic product or product? And let's look at C, unless anybody want me to do B. Hello? No. And, ooh, I've got a carboxylic acid, I have a benzene ring. Does anybody here know a reaction with potassium or sodium hydroxide and a benzene ring? Because I don't. Therefore, this is a carboxylic acid, proton, base, carboxylate anion. In this case, the metal, K plus, or potassium plus, is what the cation would be. And here's the mistake. Oh no, don't look, don't look. But obviously, when I made the answer, I was in a hurry. Let me put the right answer up. How many carbons do I have? And here, what do we have that's different? Carbonyl hydroxyl group, carboxylic acid. What are we reacting it with? A base, and there are other bases, but I'll stick to hydroxide bases in this class. And what you'll get is the carboxylate anion. What's R? These carbons. And my carbonyl, 1, 2, 3, 4, 5. My carbonyl, oxygen minus what's M plus sodium. And you can see on the problem set the mistake I made. I forgot the reactant. Well, there goes my perfect score. Ooh, let's look at 5. Anybody try taking some baking powder and vinegar and mixing them together at home? Remember the little rocket ship story, which is a true story I told you about. I still remember the really big trouble my friend Gail got in for using up all his mother's baking powder. And I told her to get more. But anyway, let's take a look at number 5, unusual question. Draw the condensed structures for all of the products of this reaction. And if we look at the top one, what do we have? We have carboxylic acid reacting with sodium bicarbonate, baking powder, to give a carboxylate anion, carbon dioxide. The arrow tells you it's given off as a gas, and water. And therefore, what's our methyl? And you get sodium acetate, water, carbon dioxide. And remember I told you that's the secret my father used to make really fine spaghetti sauce by neutralizing some of the carboxylic acid in the tomato sauce with baking powder at the end. Because sodium acetate tastes salty to your tongue, cut back on the salt, and don't forget to put a very small amount of cinnamon in there too. In fact, at my other class, I have a student who has been a chef for a catering service. He said, yeah, that's the secret, the cinnamon. And we also did the bicarb at the end. Yes?
Strange question. Is that the
Is that what?
the acid, the carbon?
Carboxylic acid.
Yes. Is that part of what causes GERD?
Was what?
GERD? Acid reflux?
Oh, okay, I didn't know the acronym. Honestly, I don't know, but I can tell you, I mentioned a story. I had a student here who, after I talked about how to make the best spaghetti sauce, weeks later came back and said it worked. And I said, oh, that's good. And she and her father suffered from acid reflux. And by lowering the acidity content, in other words, raising the pH, it helped it. Now, is that the only cause? Don't know. I'm not a medical doctor, even though I know it's a serious problem, because where I worked once, one of my colleagues had it, and he had to go in for an operation because he had it so bad. All right, on 6A, just cross that out. 6B, I just went overboard. Sometimes I have too much fun doing problems, so, oh, let me put that down. All right, let's move on. We're on the bottom of page 8, D and E. Oh, wait, let's see a hand back. No, no hand. All right, let's do E. And the question is, what's the organic product or products that are following? And if we look at this, what's different? Carboxylic acid. What do I have here? Different. Carbon, hydroxyl, alcohol. Carboxylic acid, alcohol in the presence of acid, and you did this 2 weeks ago, and you'll do it this week again, you make an ester. And if we look at E, what's our big scary group again? What's our prime? Another big scary group? Not really. You have carbonyl carbon becomes here. Oxygen, the hydrogen is replaced with R prime. R is still there, and you get that ester. And F is the same thing. Let's move on to G. Question H. What's the product or products you're following? On the actual problem set, it didn't have water. Usually you're going to have a solvent. I don't think I've ever run a, even though there is a branch in chemistry called solid state chemistry, I've never run a reaction that wasn't in solution. Never. But anyways, question is, what's the organic product or products? And, uh-oh, 2 mistakes. Let's do H. question is, what's the organic product or products for the following? We look at this, oh, benzene ring, no reaction of benzene with potassium hydroxide, because I don't, but oh, look, ester. Carbonyl, call this R, carbons. Oxygen, more carbons, R prime. And base, MOH, water, and what you get are two things. The carboxylate anion, the carboxylic acid you would have used to make that, and the alcohol. The mistake I made is I had the wrong cation. What's R? Benzene ring with a methyl group. Mistake I made is my cation should be potassium. And then R prime, ethyl, so you'll get ethanol. And we'll learn next week or this week that this reaction our ancestors used to make soap. Continuing on, 7, the same thing, draw the structure for the organic product or products of the following reaction. And if we look at A, B, and C, they're the same reaction. Anybody have a favorite? All right, I'll pick A. If we look at this, what do I have? What's different? Carbonyl, oxygen, carbons here, ester. What am I reacting with? Acid, water, acid hydrolysis of an ester. You'll learn later on in a couple of weeks that this is how your body breaks down all fats and oils in your stomach. By the way, your stomach is a walking chemical plant. A lot of reactions going there, organic reactions going on. Now what do we have? Ester, acid, water. What's R? 3 carbons, R prime, isopropyl. This becomes butanoic acid. The carbon in R prime with the oxygen will be the carbon that has the hydroxyl group, isopropyl alcohol. And all I've done in B was change the R groups. And that is the strength of functional group organic chemistry. You just don't have, here's one example, and if you change something, is it something different? Well, if it's the same functional group, the answer is no. And here's another example. Ester, acid, water, acid hydrolysis. Here's my R, here's my R prime. So I don't know the reaction of benzene ring with acid and water. You'll get this carboxylic acid and this alcohol, phenol. All right, let's move on. D and E, time for a water break. You know, one of the things I always do on a problem set once in a while on a test, I try not to, but I forget to put 2 there because organic chemists at my level don't ever balance things, but for you I will always try to. What's the product or product of the following? Ester, carbonyl, oxygen. What's that? Carbon, magnesium chloride, Grignard. There are 2 of them. What do you get? Second step, acid and water. Grignard reacting with an ester. Keep your eye on the carbonyl carbon. The R group here is still bonded to that carbon. And now you get to make something special. Very rare in organic chemistry. Not 1, but 2 carbon-carbon single bonds from the Grignard to the same carbon that was the carbonyl becomes the alcohol. This part here becomes another alcohol. Therefore, R benzene ring, R triple prime methyls, you'll get that alcohol. R prime methyl, you'll get methyl. And to show you what sort of really nice molecules you can make, let's look at F. And F would be, give the organic product or the products for the following. Here I have, not too complex, ester, and ester, magnesium bromide, Grignard. What's this R? What's attached to carbonyl? Will be attached to this carbon with the alcohol. My R triple prime are ethyls. My R prime gives me ethanol. Now, this reaction, I'll never put a synthesis problem, but I will put some synthesis problems. You notice on here I didn't have any, because any reaction here, other than the ones I told you I wouldn't put on a test, all you have to do is the following. And the question would be, give the organic starting material for the following. And I'm going to let you try this one out yourself. Because I've gone this whole amount of time and I haven't shared it yet. I don't know if you heard me, but I'll do it a little louder. Big hint.
That plus sign on the other side, is that connected, like?
Two separate things. The plus means they're separate things.
Well, it's down low, so I was wondering if that's
No,
supposed to
this,
be.
oh, I drew it.
Okay.
And on test 3, I'll have 3 or 4 synthesis problems, about 9 or 12 points, so don't forget to practice it. All right, let's take a look at this. Question is, what would be the starting material? And the first thing you would have to make that by reacting something with acid and water. And the first thing you should do is say, what's different? Ooh, carbonyl. Hydroxyl group, carbons here, I'll call that R. Carboxylic acid. What's different here? Ooh, carbon with the hydroxyl group, I'll call this R prime. Remember, R and R prime are just like in math, X and Y. You can name either one, whatever. I tend to do it this way. Most organic chemists do. What do I react to get a carboxylic acid and alcohol? An ester. What's R prime? Methyl. What's R? Ethyl. I'll have my carbonyl, my oxygen. There's my R prime. The carbon with the hydroxyl group will be the carbon bonded to the oxygen there. There's only one. And there you go. going to try this one. What would be the starting materials to make the following product? All right, looks like everybody's done. I still can't find the second eraser, but must have walked. All right, let's take a look at this. What would be the organic product of products of the following? What's different here? Carbonyl, oxygen. On the carbonyl, I have carbons. On the oxygen here, I have carbons. Ester. What do you react with acid? Well, you know, because you did this twice 2 weeks ago. A carboxylic acid plus an alcohol. What's R? Methyl. So you can think of acetic acid. What's R prime? Ethyl. Therefore, the other question mark is ethanol. And that's how you do synthesis. Any questions? Any questions at all on carboxylic acids, carboxylate anions, or esters? Anybody happen to think about if you had a banana and you smelled it and tasted it, and that was an ester? Quick reminder with the warmer weather, don't forget in lab, no open-toed shoes, no flip-flops, no open midriff, no spaghetti tops, especially this week's lab, make sure you have a long sleeve top.
Do you want us ready to go before lab, or can we?
Well,
Do you want us ready to go before lab, or can we go to the rapid to change?
as long as we're not starting, you've got the proper clothes on. I don't know if I told the story a couple of years ago. Remember we had that super hot summer? It was like 95 at 9 o'clock at night for a couple of weeks. Well, I was teaching this course in the summer and I was in night class. And I was coming from the parking lot here in the building. It was about 4:30 in the afternoon. It was like 98 or 100 out. Here I am with a long sleeve top on. And people are looking at me, are you nuts? And I was thinking, well, you can tell me and my students, we either have lab coats or we're wearing long sleeve tops. All right, I started talking about last week, amides. Amides are a derivative of a carboxylic acid where you replace the hydroxy group with a nitrogen, and that nitrogen can have things on there, R and R prime. Now, in amides, R prime and R double prime can be both or one hydrogens. I guess R could also, because that'd be an amide of formic acid, form amide. Now, good news, I'm not asking you to learn any nomenclature of amides. I believe I finished where I was talking about urea. Urea is the simple, one of the simple amides. Turns out that at first glance you say, it doesn't look like an amide. Let me draw it a little close, differently. And if I were to say, oh, there's an R group under my hand, you say, oh, that's an amide. And if I said, oh, there's an R group under my hand, that's an amide. And it turns out this is urea. It's a white solid at room temperature, and it reacts like other amides. In fact, I've worked with it a lot in industry. It's used to make resins. Resins is a fancy name for glue. And if you look at your desktop, it's different layers of thin laminate wood or wood glued together. And one of the glues is made from urea and formaldehyde. Hi. And also urea, as I pointed out, is the major organic chemical in urine. It's your body's way of getting rid of nitrogen, one of them. Now I'm well beyond the level of my expertise in medicine. And I talked about how peppers has this amide. Let's talk about how you make an amide. Generally, you have to heat this. You take a carboxylic acid, react it with ammonia under the right conditions. You have nucleophilic attack of the nitrogen on the carbonyl carbon. Oh, quick. Take a picture. Rare moment, I'm putting down something inorganic. Because when I don't, students get upset. What happened to the other stuff? You take a carboxylic acid, react it with ammonia, you will get an amide. In this case, R and R prime and R double prime are both hydrogens. So if I look at this reaction, the question is, what's the organic product or products are the following? And you look at what's different. Carbonyl, hydroxyl carbon, carboxylic acid. Ooh, ammonia, inorganic stuff, that's different too. And what do you get? An amide. What's our R group? 2 carbons. What amide do we get? You get that amide. For your fun and enjoyment on this spring weather day, what would be the organic product or products for the following? It was like the last. Carbons just went down. If I look at this and say, what functional group am I dealing with? What's different? Carbonyl hydroxyl group carbons, carboxylic acid. Ooh, ammonia. What do you get? An amide. You don't have to put the water down because we're interested in organic products. And therefore, what's my R group? Isopropyl. Keep your eye on the carbonyl carbon, because that's where the fun is. And what do you get? This amide. And that's how you make simple, they're called primary amides. Now, one of the questions I always ask you to ask of me, and while you're sitting here in this class, is why am I learning this stuff? And the obvious answer is you want to get a good grade. If someone said you have to take this class to get in a program or a school, but why else? What about amides? Well, it turns out when you have an amide of this form, when R plus the carbonyl is about 20 carbons, very long R chain, that comes from what's called commonly erucic acid, and it's called erucimate, it's a common name. Well, why are you talking about erucimate? How many of you have ever been in a supermarket and you go to the produce section, you know how they have the bags on the rolls, and you take one off to put in your produce you're picking? And you take it off the roll, and nowadays it says open this end. Before they didn't used to have that. Now you do, and you go like this, it won't open. It's just stuck together. You try and try. Well, the reason why is the company that made that bag was cheap. There's a compound, amides, they're called slip reagents. And erucimate is one of them. How do I know? Because I worked for a company that made it. I worked on a research project, which I did to make a high purity, low color erucimate. And if you notice this plastic bag comes apart real easy, there's a lot of erucimate. It helps the plastic slip apart. And when you get a bag like that that won't open, the company who made it was cheap and didn't put a lot of erucimate or maybe none in there, and it's just stuck together. What you should do is go to another roll, because you're wasting your time at that roll. And hopefully that roll, they have enough erucimate in there. Now, another reason why you should learn about amides, now it's time for Dr. White to scare you, no, not really. And how many of you like to see an amide real quick? Look at your skin. How many of you have heard of peptide bonds? And we'll come back to this. Peptide bonds are really amides. And therefore your skin and your hair, which I have left, and my beard, that's still here. But anyway, those are all amino acids held together in amide linkages. And we'll cover that. We do go into proteins and amino acids later on. But all you have to do is look at your skin and say, ooh, lots of amides. All right, now, how else can you make an amide? To make a more complex amide, instead of dealing with ammonia, you can react a carboxylic acid with either a primary or secondary amine. And if we take a carboxylic acid and react it with an amine, you'll make an amide. By the way, the company I worked for, we used to make about 10 million pounds a year with that one amide. We made a lot of everything. But anyways, we also did this reaction, take a carboxylic acid, react it with an amine, and what you get is an amide. Remember, R prime and R double prime can be hydrogen. And now things get a little tricky, but I think you're up to it. Let's look at what we have here. If I look at the first one, what's different? Carbonyl, hydroxyl group, carbons, carboxylic acid. Now I look at this one, ooh, nitrogen. It's got a methyl group and 2 hydrogens. Well, this I can call R prime, and one of these hydrogens I'll call R double prime, which is the form of an amine. And what am I going to get? An amide. Keep your eye on the carbonyl carbon, carbon double bond to oxygen, because that's where the fun is. And I'm going to draw that first. Then my nitrogen. What's on this carbonyl carbon? My R. Methyl. What's on my nitrogen? R prime and R double prime. Notice one is methyl and the other is a hydrogen. You can put those any order you want, and that's the amide you get. And you'll learn later in the semester, Mother Nature uses this reaction extensively to make all the proteins in our life. Boy, time flies when you're having fun with the amides. And why don't you try this one? Get the organic product or products that are following. Remember, those of you who have lab tomorrow, don't forget to wear a long sleeve top or bring a lab coat. And no shorts or other things allowed in the lab. All right, 6.2 seconds left. 2, 1, bonus 2 seconds. Time's up. Let's take a look at this because I'm running out of time. And we look at what's different. Carbonyl, hydroxyl group, carbons, carboxylic acid. Carbon, ooh, nitrogen, carbons, an amine. What do you get? An amide. What's R? This. One of these I can call R prime. The other R double prime. Write my carbonyl first with my nitrogen. What's R? 2 carbons. And what's R prime? Methyl. What's R double prime? Ethyl. And I only want 5 seconds over. With that, I'll see you tomorrow. Don't forget, go to the lab, wear proper clothing, and enjoy the weather. What? Yeah.